Hello Internet, I have returned with making more maths videos. So, I'm gonna say hello. Hello! Yeah, too loud. Okay, so today we are going to learn how to make a unit circle. A unit circle. Unit circles are very useful in trigonometry and trigonometric functions, which we are going to be talking more about. It's the unit my precalculus class was in this last unit. So, yes, that's what we're doing today. Enough babbling, like an idle babbling brook. Okay, so a unit circle. Let's define it. Unit circle. A unit circle is a circle whose radius, or radius, just kidding, is 1, and whose, yes, it is a person, whose center is, or B if you are a pirate, at the origin of a rectangular coordinate system. I should have just written this down and read it to save time. But who cares about that, right? Right? Yeah, you're probably scrambling before your final. Yeah, I'm sure you are. Okay, so a circle whose radius is 1 and whose center is at the origin. If its radius is 1, then its circumference will be 1 times the radius times 2 pi. So, oh my goodness, circle. Circumference. Doesn't that look great? Ference is radius times 2 pi, which is 2 pi because radius is 1. This makes a lot of things easier for us. Isn't that great? So one rotation around it then, one rotation around the unit circle is 2 pi radians. And that's the same as also 360 degrees. Wow, like a regular old circle. Isn't that just nifty? All right, so now let's get down to the nitty gritty. I've been saying that a lot lately. I watched Nacho Libre the other day. Sponsor! Just kidding. Wow. Okay. So, the definition. We have a rectangular coordinate system. Good old X and Y axis. So we got the Y axis and the X axis. Okay, and the circle whose radius is 1. So let's just say this is 1, 1, 1. So this is the point 1, 0, 0, negative 1, negative 1, 0, 0, 1. Okay, this is the best circle I have ever drawn. Yeah, all right. Make sure you can see it clearly, because I can't, but I don't know if you can. Okay, so this point here will be 2 pi radians, or 360 degrees. Things are going to get really crazy in here, let me tell you. This point will be 90 degrees. Just running out of space with this stupid fat pen. Or pi over 2, because this is 2 pi, then half of 2 pi is 1 pi, and half of pi is pi over 2. And half of that then is pi over 4, and half of 90 degrees is 45 degrees. We're also going to have points in here at 30 degrees and 60 degrees. So 30 degrees and 60 degrees. And counterintuitively, as we love to do things, 30 degrees is pi over 6. And 60 degrees is pi over 3. Look at that. 3, 6, 6, 3. Great. All right, now let's get really crazy and fill in the rest of it. So this point here will be pi. Pi. 2 pi, pi. So pi is half of a circle. So then we have pi over 4. This is 2 pi over 4 is pi over 2. So then next will be 3 pi over 4. 3 pi over 4 Okay, and that is the same as 135 degrees, cheat sheet, which is also 90 plus 45. 90 plus 30 then is 120. And, okay, if you're doing this from memory, which you might have to do for a test, here's how to remember this. From here to here is 1/3 pi, or pi over 3. And here's another third pi. So it's another pi over 3. So what then is this? It's 2 pi over 3. 2 pi over 3. So if we count in terms of pi over 6, then we have pi over 6, 2 pi over 6, which simplifies to pi over 3. 3 pi over 6 simplifies to pi over 2. 4 pi over 6 simplifies to 2 pi over 3. And finally, 5 pi over 6 simplifies. Doesn't simplify because it is 5 pi over 6. And this, using my cheat sheet, is 150 degrees. Okay, and another way we can remember this is pi is 6 pi over 6. So 6 pi over 6 minus pi over 6 is 5 pi over 6. Isn't that just lovely, dandy, wonderful? Yes, I answered that for you. Okay, let's just do the rest of the 45 degree terms. So we have 3 pi over 4, 4 pi over 4 cancels to pi, 5 pi over 4, and then 6 pi over 4, which simplifies to 3 pi over 2. Bloop. And then 5 pi over 4, 6 pi over 4, 7 pi over 4. Since this is 2 pi, it's 8 pi over 4. So 8 pi over 4 minus pi over 4, 7 pi over 4. Isn't this just lovely? It all makes sense in some sort of sick, twisted way. Just kidding, it's okay. So next, let's do pi over 6s. 5 pi over 6, 6 pi over 6, 7 pi over 6. 7 pi over 6. And that, oh, I didn't write the degree terms of these. 7 pi over 6 is 210 degrees. 5 pi over 4 is 225, which is 210 plus 15. 3 pi over 2 is 270 degrees. 7 pi over 4 is 315 degrees. Okay, get a couple more. Oh, this is 180. 180 degrees. Make a 180 degree turn. Turn right on around. Okay, 7 pi over 6, 8 pi over 6. 8 pi over 6 simplifies to 4 pi over 3. And if you look at this, 7, 5, 4. Okay, that almost makes some sort of sense, but it doesn't. So never mind. 240 degrees. Now I'm really confusing you. Okay, 4 pi over 3, or 8 pi over 6, 9 pi over 6, simplifies to 3 pi over 2, 10 pi over 6, 10 pi over 6, simplifies to 5 pi over 3. And that is 300 degrees. And 10 pi over 3, 11 pi over 6. And there we have it, 11 pi over 6. And 2 pi is 12 pi over 6. 12 pi over 6 minus pi over 6 is 11 pi over 6. 360 degrees minus 30 degrees is 330 degrees. All right. All you have to know really for this is addition and subtraction. Okay, now, each of these angles has a corresponding point. Here's a point, here's a point, here's a point, here's a point. Okay, so this point here at 2 pi is the point 1, 0. All right, the radius is 1. So unfortunately, that does not mean that each of these points will be like 1 something or something 1, but they have something else. But we have them set and memorized, and this is a trick that I learned on the YouTube. So I'm kind of almost plagiarizing. I don't know. I don't remember who it was. I know there are lots of videos that tell you how to do this, but here's how you do it. Okay, you write 2 on the bottoms. So these are the points. We are making fractions. So you write little 2's on the bottom. Doot, 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 lines over them. And here is the awesome part. You start from the outside bottom and you go 1, 2, 3. And then you go back, start top inside, 1, 2, 3. And if it's a 2 or a 3, then you put a square root over it. And there you have your x and y coordinates for each of these. But, you may be saying, what about the rest of them? Well, we can use the fact that this is a circle and everything kind of reflects, and the fact that we know that everything on this side of the x-axis will be negative. Everything on this side of the y-axis will be negative. And this side of the x-axis is positive. This side of the y-axis is positive. I am really going to confuse you, right? Also known as quadrants 1, 2, in Roman numerals, 3, and 4. This thing's really taken on a personality of its own. To find the rest of these. Okay, so what we do is we look at the corresponding denominators. Pi over 3. This one's 2 pi over 3. So we're going to write basically the same coordinates. 1/2 and -3, or square root of 3 over 2. We know, though, this is quadrant 2, so it is to the left of the y-axis, so the x-coordinate will be negative, but it's still above the x-axis, so the y-coordinate is positive. Then for this one, we take it, square root of 2 over square root of 2, and square root of 2 over 2. Sorry, not square root of 2. That's negative, 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 positive. Same thing. And this one, pi over 6, negative square root of 3 over 2, 1/2. But you may be thinking, what about the bottom half? Here's the thing. You just look at the corresponding denominator. I don't want to circle that in Sharpie. Okay, you look at the corresponding denominator. So this is pi over 6. This is 7 pi over 6. So we're going to use these coordinates. But it's in the third quadrant, which means it's below the x-axis and to the left of the y-axis, which means both of the numbers will be negative. So we say negative 3 pi over, negative square root of 3 over 2, and negative 1/2. Okay, pi over 4, negative square root of 2 over 2, negative square root of 2 over 2, and 4 pi over 3. So this corresponds with the pi over 3, negative 1/2, negative square root of 3 over 2. All right, we'll be back after these messages, and I will show you how to do trigonometric functions using these things. So, hold on to your pantaloons. Oh, hold on. Wait, one more thing. This is also, we forgot these points. These points will be 0, 1, since it's the radius of 1. -1, 0, and 0, -1. And to find these, use the same trick we used for all these, okay? All right, have fun.